Learning goals. Welcome to this learning session on understanding probability and expected frequency. In this course, we shall address what is probability, calculating simple probabilities, understanding expected frequency, applying expected frequency, real-world probability applications. There will be a quiz at the end to test your knowledge.
What is probability? Probability quantifies the likelihood of an event occurring, ranging from impossible to certain. It is a fundamental concept in mathematics and statistics, helping us understand uncertainty. For instance, predicting the outcome of a coin toss or the chance of rain involves probability. Probabilities can be expressed in three common forms: fractions, decimals, or percentages. For example, a 60% chance of rain can be written as 60/100, a fraction, or 0.6, a decimal. These different representations convey the same information about likelihood. Understanding these forms allows for easier comparison and calculation of probabilities in various contexts. For example, a weather forecast might state a 75% chance of snow, which is equivalent to 3/4 or 0.75, making it easy to grasp the high likelihood. Probability for equally likely outcomes. For events where each outcome has an identical chance of occurring, probability is calculated using a simple ratio. This applies to situations like rolling a fair six-sided die, where each number from 1 to 6 is equally likely to be rolled. Similarly, drawing a card from a well-shuffled deck means each of the 52 cards has an equal chance of being selected. The formula for the probability of an event is the number of successful outcomes divided by the total number of possible outcomes. This principle is foundational for many probability calculations. For example, if you want to roll an even number on a die, there are 3 successful outcomes, 2, 4, 6, out of 6 total outcomes, so the probability is 3/6, or 1/2. A key characteristic of equally likely events is that the sum of probabilities for all possible outcomes must always equal 1 or 100%. This ensures that all potential results are accounted for. For instance, the probability of rolling a 1, 2, 3, 4, 5, or 6 on a die, each being 1/6, sums up to 6 to 1/6 equals 1. Let's apply the probability formula to a common scenario: a bag containing beads. Imagine a bag with 3 red beads and 4 black beads. Let's apply the probability formula to a common scenario: a bag containing beads. Imagine a bag with 3 red beads and 4 black beads. If one bead is taken out at random, we can determine the probability of it being red. To find this probability, we first count the number of successful outcomes, which is the number of red beads, 3. Then, we count the total number of possible outcomes, which is the total number of beads in the bag. 3 red plus 4 black equals 7 beads. Therefore, the probability of picking a red bead is 3/7. This simple example illustrates how to directly apply the formula by identifying the specific favorable outcomes against the entire set of possibilities. Predicting event occurrences. Expected frequency. Expected frequency is a prediction of how many times an event is likely to occur over a given number of trials. It's a powerful tool for forecasting, allowing us to estimate future outcomes based on known probabilities. For example, a business might use expected frequency to predict how many defective items to anticipate in a production run. The formula for expected frequency is straightforward: the probability of an event multiplied by the total number of trials. This calculation provides a theoretical estimate, not a guarantee. It's crucial to remember that actual results can, and often do, vary from the expected frequency due to random chance. Consider a scenario where a basketball player has a 70% free throw success rate. If they take 100 free throws, the expected frequency of successful shots would be 70. However, in reality, They might make 68, 72, or any other number of shots, highlighting the difference between theoretical expectation and actual observation. Applying expected frequency to scenarios. Let's apply the expected frequency concept to a fair six-sided die. If we want to find the probability of rolling a number greater than 4, the successful outcomes are 5 and 6. There are 2 successful outcomes out of 6 total possible outcomes, so P number 4 equals 2, 6. Now, if this die is rolled 100 times, we can estimate the number of times we would expect to roll a number greater than 4. Using the formula, expected frequency equals P number 4 comes number of trials. This becomes 2, 6, 100. Calculating this, 2, 6, 100ths equals approximately 33.33. Since we cannot roll a fraction of a time, we round this to the nearest whole number. Therefore, you would expect to roll a number greater than 4 approximately 33 times out of 100 rolls. Real-world applications of probability. Probability is not just a theoretical concept. It's deeply embedded in many real-world applications, influencing decisions across various fields. From predicting weather patterns to assessing risks in financial markets, understanding probability helps individuals and organizations make more informed choices. In games of chance, such as lotteries or card games, probability helps players understand their odds, even if it doesn't guarantee a win. Insurance companies heavily rely on probability to calculate premiums, assessing the likelihood of events like accidents or illnesses to determine fair costs. Furthermore, in scientific research and medical trials, probability is used to determine the significance of results and the effectiveness of new treatments. For example, a p-value in statistics, derived from probability, helps researchers decide if their findings are likely due to chance or a real effect.
Summary. Well done, you have completed the course Understanding Probability and Expected Frequency. You should now be familiar with what is probability, calculating simple probabilities, understanding expected frequency, applying expected frequency, real-world probability applications. Should you need to revisit any of the topics in this course, please use the menu at the bottom of the screen.